All right, welcome to Chapter 3, Section 1. So if you remember back, we skipped the first couple sections of this chapter. Now we're going to go back, hit these highlights of these first two sections that we skipped, which is introductory level stuff. Shouldn't be anything too crazy. Once we hit through this section in 3.2, we will be ready for our Chapter 3 test. So let's work on understanding a few things here. With the concepts of linear equations being emphasized, that's what's important. We're talking about lines. The example 1 type problems are going to be understanding the equations in what we're going to call standard form. So this standard form thing means it needs to be written in the form ax plus b y equals c. In other words, what does that mean? A, B, and C are all just numbers, constants, some value. A, B, and C are just numbers. So what else do we notice here? So A some number times x plus some number times y. We have our x's and our y's on the same side of our equation, and it's equal to some number. So standard form basically just means put your x's and your y's on the same side, and you want your x's to be positive. So that's it. Keep your x's on the same side. They should equal some number. That's our standard form. The second part of these types of questions, they're asking us, is it a linear equation? So usually it will be a linear equation, but what do we know about linear equations? What do we know about lines? They're to the power of 1, right? So it has to be to the power of 1. Can't be squared, can't be cubed. And we also can't have any variable in the denominator. So let's look at this one. We want to determine, is this a linear equation? So what we want to do is solve for y. So we know lines, we like to have our lines in slope-intercept form, which is y equals mx plus b. So if we try to create this out of this, let's get y by itself and see if we have something that looks like it's that form. So first, to get y alone, I'll divide both sides by x. So on the left, those go away. We get y equals 6 over x. Now y equals 6 over x. We have y by itself, so we're done. There's nothing else we can do. Notice we have a variable in the denominator, and that is something we have to look out for, because this is something that is not a line. This is going to create what we call an asymptote, and you don't have to know that word, but it makes a really funky graph, and it's not a line. Okay, variable in your denominator is not okay. So to answer the question, is this linear? No, it definitely is not. We know it's not because there's a variable in the denominator. So for 1A, the answer is no. Now 1B, same process. So all the example 1 problems are going to have the same directions. So as we look at 1B, we see y equals 2 minus 3x. So let's remember, we want to check and see, can we make it in the form y equals mx plus b? So we want to be able to check, is it a line? This will allow us to do that. So y equals, my x is the second term here, so I want to make that the first term. So let's just switch the order of these two things. So I can rewrite this as y equals negative 3x plus 2. So notice what I did there. All I did was take the second term and write it first, and the first term and write it second. So we have those two things. I switched the order. Now we're looking at this, and we see this is in this form, mx plus b. Some number times x plus another number. So is this a line? Absolutely it is. It fits this mold, so we know that it's a line. So to answer the first part of the question, is it a line? Yes, we know it is. Now, if we use our reading comprehension skills, we go back and read the question. It says, if yes, write the equation in standard form. So, the second part I will do in blue. We need to now write this equation in standard form. Now remember we said, and we should have this down as notes, standard form is some number times x plus some number times y equaling a third number. So we need our x's and our y's on the same side of the equation. So, looking at what I already have, to get this x over here, how can I do that? Well, I need to add 3x to both sides to get this to cancel out. If I add 3x over here, these cancel out, that goes away. And then over here, I just get 3x plus y. So when I add all this together and bring it down, my standard form, 3x taken here, plus y equals, what's left on the right? Just 2. 3x plus y equals 2. Is this in standard form? Absolutely. We have a, some number 3, times x, plus just y, equals some number c. So this is what we need to have, x's and y's in the same time, equaling some number. That is standard form for 1b. Now 1c, we can follow the same logic, so we know what the directions are asking us. First check, is it a line? First check, is it a line? Second, if it is, write it in standard form. So is this thing a line? In other words, can I write it in y equals mx plus b form, and does it make sense? Is it to the power of 1? So we can check all those things. So I need to get y by itself, but we have this minus 4 thing here. I don't want that. So I'm going to go ahead and add 4 to both sides and see where that gets me. So on the right, we know these will cancel out. So I'll get just y. And we'll have that equal to 5x plus 4. So looking at this, is this to the power of 1? Yes. Is there anything, a variable in the denominator? No. So there's nothing weird going on. So we can say, yes, this is a line. So first part, yes, it is a line. Now we know it's a line. Now we need to put it in standard form, part 2 here. So second part. Write it in the form with x and y on the same side of your equation, equaling some number. So let's bring the x's and the y's on the same side. My x is already over here, but I need to bring the y's over there as well. So what operation can I do to get rid of the y on the right and to end up with a y on the left? Well, we know if we subtract y from both sides, this will cancel out. And over here we'll get a y. So this will go away. And on the left we'll have 5x minus y plus 4 equals 0. So we have all those things. Now, what do we know about our standard form? Well, we want just x's and y's, and any numbers left over should be on the right side. So this negative 4 we don't want on the same side as our variables, as our letters. So we need to get rid of that. How do we do that? What's the opposite operation? Subtract. So we subtract 4 from both sides. This will go away now. On the left we'll have just 5x minus y equals a negative 4. Now is this in the right form? Some number times x, okay? And some number times y, just y, equals some number negative 4. So x's and y's on the same side equaling some number, that's what we want. Just keep in mind, the negative y, it doesn't matter if the y is positive or negative as long as they are on the same side. So this is our standard form answer for 1t. Now 1d. Quickly, we can look at this and try to understand, is this indeed a line? So one rule we said to look out for is the powers. And what do we know about lines? They're always to the power of 1, right? Anything squared, cubed, to the 4th, to the 5th, those are huge things that change very fast. They're not constant in any way, and those are not linear. So, looking at this, we see right here we have a superscript 2. That means it is squared. That is to the power of 2. That's going to actually give us what we call a quadratic equation, which is very different from a line. So power of 2, right away we know that's not to the power of 1. This thing is not a line. So to answer the question, is it a linear equation? We know the answer is no. And that's all we need to say for 1D given that equation. So hopefully have that down. And just keep in mind, the powers have to be to the power of 1 for anything to ever be a line. So that's a shortcut to make these problems simpler. Now 1E, same process. Is this thing a line? So we know we always want to try to check by getting our materials here, our equation, in this form. So we know we want y by itself. So take this 4. We will add to both sides. Over here this becomes a 0, and over here we'll get just 4. So with one step, we see that y equals 4, but now we need to check, is this thing a line? So what do we notice? We notice that there is no x value, but this is actually still a line, and it's a special case of a line where there is no x value. So lines that are y equals are actually perfectly horizontal lines. So if you have a coordinate plane, y equals 4, if you go up to 4, y equals 4 would be a flat line, pretending this is flat. Y equals 4 would be a flat line that goes in that direction along where y is 4 everywhere, going left and right. So that's still a line even though there's no x. So anything that says y equals some number is a horizontal line. Anything that says x equals some number is a vertical line. So keep those two things in mind. They're actually simpler, and they are always lines. So if you see anything like that, is it a linear equation? Yes. That answers the first part. The second part wants it in standard form. Standard form means x's and y's on the same side, equaling some number. There is no x, so y is on the side by itself, and it equals some number. So that is the best it is going to get. That is in standard form. So yes, and you leave it as is. We did both of those things for 1E. So remember, these are shorter and they're always lines. So 1F, quickly we can look at this and determine, is 1/2 times y equal to 1? So we can multiply. We want only 1y, not 1/2 y. So if I multiply both sides by 2, let's see what happens. So 2 times 1/2 gives me 1. That's just 1y. So I'll write y. That's equal to 2 times 1, which we know is 2. So we've got y by itself. Y equals 2. Is this a linear equation? Well, we just said y equaling some number. Y equaling some number is always a horizontal line. So is this linear? Absolutely. We know that to be true. Second part, is this in standard form? Yes, it is, because there are no x's, the y is by itself, and it equals some number, in this case a2. So that is standard form, and we are done on 1F. So have this equation, yes, and standard form is already given. So the second type of problem that we're going to see is finding the intercepts. So we can find the x and y intercepts of each of these things. So this term intercept just means where it crosses whatever axis we're talking about. So where does it cross the x-axis? Where does our line cross the y-axis? Those are the things we need to know. So this is my y, here's my x. Now I notice this line crosses the x-axis right here, crosses the y-axis right here. So my x-intercept, where does it cross? My x-intercept is going to be, what's the value of x? 1, 2. Very simple. Now what's my y-intercept going to be? Where does it intercept? Where does it cross the y-axis? What's that value? So it crosses here. That's a negative 1, 2. And that is it for 2a. These are problems you should like because it's just where does it cross those axes, and you have the numbers and you're good to go. So 2a, x-intercept is 2, y-intercept is negative 2. Have a little image of the drawing down. Don't worry about the directions as we move on. 2 and negative 2. Okay, now we want to find the intercepts for this one. So 2b, I know my intercept is here for the y, here for the x. So my x-intercept, if I count, I have 1, 2, 3, positive 4. What's my y-intercept going to be? 1, 2, 3, positive 4. And those are my intercepts. So having a graph makes these very quick and easy to see where does it cross those axes. Make sure you keep x and y straight. X is always horizontal, y goes up and down. So 4 and 4 for 2b. 2c, what are the intercepts here? We've got y up here, x about here. So my x-intercept is going to be 1, 2. My y-intercept is going to be 1, 2, 3, and 4. So make sure you're keeping track of what's positive and negative. These are both positive. Negatives will go to the left for x and down for y. So we have those two there, and those are our intercepts for 2c. So try to have yourself a little image of the line crossing so you can have that to reflect on for 2c. Now, the third type of problem we will see will ask us to graph making some kind of a table. So when they say a table, we really just need to have x, have y, we'll have a column, and then we'll plot some points here. So we want to have some points to call on that allow us to draw a graph. So let's say I want to pick easy values. So low numbers around 0. So I'll just pick 3 points, -1, 0, and +1. So when x is a -1, what is y? Well, if I look at my graph, y equals 4. What does this whole statement mean? Well, there's no x, so this means y is always 4. Y is 4 every time, no matter what x we put in. So when x is -1, y is 4. When x is 0, y is 4. And when x is 1, y is 4 again. So if we plot all of these 3 points, that'll give us our graph. So -1 for x, up to 1, 2, 3, 4. 0 for x, up to 4. And 1 for x, up to 4. So those points I can then connect with a line. And that is the graph of this equation. Y equals 4 is just a flat line. And we already talked about that. How anything that is y equals is always a flat line. And anything that's x equals is a vertical line. So have this little arrow down as your graph for 3a using your table. All right. So 3b, we want to graph this equation by making a table. So we'll do the same process. So taking my x and y, I want to pick 3 points. So let's pick numbers that are easy. I'll pick low numbers around 0. And we'll get these y values out. So if I plug in a -1, what do I get out? Well, -1 plus 4 is going to give me 3. So when I plug in a -1, I get out a 3. If I plug in a 0, what do I get out? Well, if x is 0, I get 0 plus 4, which is 4. And you can see a pattern emerging here with the y's. They go up by 1 each time. So if I plug in a 1, what do I get? Well, 1 plus 4 is 5. Now, we have 3 points. We can take those and plot them, and that'll give us the pattern of our line. So -1 up to 1, 2, 3. 0 up to 1, 2, 3, 4. And 1 over 2, 5. So now I can draw my line. I'll put an arrow going up there and down across these squares, and that will reach the edge of my graph. I'll draw an arrow, and this is the extent of this line. So let's check. We know it has a slope of 1, which checks out here. It's positive, it's going up to the right, so that all makes sense. And it has a y-intercept of a positive 4, which we know is true right here. That's also shown in this point. A y-intercept is when x is 0. So that's our graph. Given these points, use the table, pick 3 points, make them easy, pick low numbers, plot them, and get your line. So that is 3b, the third type of example we will see. Now the fourth type of example will ask us to use our intercepts to draw a graph. So given this thing here, we want to check what are the intercepts. So my x-intercept will be when y is 0. It's always when the other variable is 0. My y-intercept will be when x is 0. So let's do the y-intercept first. So my y-intercept will be when x is 0. So 10 times 0 equals -5y. So what's my y-intercept going to be? Well, 0 equals -5y. And if I divide both sides by -5, y would equal 0. So my y-intercept is at y equals 0. Right here. What is my x-intercept going to be? Well, if I plug in a 0 for y, what do I get? Well, 10x equals, if I plug in a 0 for y, this whole thing becomes 0. -5 times 0 is 0. So 10 times what number gives me 0? X equals 0. So the x-intercept is also 0. So what actually is happening here? Our graph is going through the origin. So that is going to be our intercepts for 4a. They're both 0. So have these down for 4a. Now 4b, we can use the intercepts here, and this one should be a little more interesting to have a graph for this thing. So if I want the x-intercept, I'll put in a 0 for y. So this becomes 0 plus 6, which is just 6, and that's equal to 4x. If I divide both sides by 4, x will equal 3 halves. So what do I know here? 3 halves is the x-intercept. So I'll go over to 1, and then a little bit more. Now what's my y-intercept going to be? That's when x is 0. So plug in a 0 for x. So 0 equals 2y plus 6. Now I'll need 2 more steps to solve this. So I'll subtract 6. So -6 would equal 2 times y. Divide both sides by 2. And -3 equals y. So y equals -3. -3 is the y-intercept. So go down, 1, 2, 3. Now you have your 2 points. We can connect those with a line. And now we've graphed that using those intercepts. So this is how that looks. You can graph finding these, plug in 0 for the other thing, simplify, and solve. So you should be good to go on this section given those examples. So let's get started with some work, and good luck.